All right, we are into chapter 3.1. This is IB year 1. Today we're going to talk about collecting and organizing univariate data. And as it says here, that univariate data is just data that has one variable. So we're only changing one thing. It can be shoe size, it can be pant size, and some of our problems are going to be up. Colors, what's your favorite color? So it's just one variable that's changing, one thing that we're collecting data on. You can read through this little paragraph here. It's talking about how somebody works at a restaurant and they have to put all their tips into one jar. And at the end of the month, they're equally divided among everybody who works. So the manager is just kind of interested in trying to decipher how to make use of like when the tips are coming in. What can we do with this data? And so Rosa here is the one that's tasked with every day or every week or whatever, has to collect 5 cents, 10 cents, 20 cents, 50 cents, dollar, $5, $10, and $20. I'm assuming those are euros instead, but we're going to go with dollars. And then she has to present it back to the staff. So the question that she's asking is like, what's the best way to present this data? There's a multitude of ways you can work on this data. If we're talking about these values here, those values, we could possibly make a pie chart, and we could say the number of nickels that came in, the number of dimes, 20 cents. I'm guessing they must have a 20-cent mark, 50 cents, dollar, $5, $10, and $20. So it's kind of interesting on that one, right? We don't have a 20-cent coin. They must have a 20-cent coin. If anybody can verify that, I'm not going to look it up right now because I'm in the middle of a video. But what we need to do is, a pie chart would be great, right? So you can say, hey, looks like we're getting a lot of 5-cent tips. So what can we do with that? Start looking at your menu maybe and say, hey, look, this costs 95 cents. People are leaving $1 then because they're leaving that 5 cents for that remains to left to go to tip. That'd be something they could change. Maybe they have to make it go up to $1 so that people have to leave their own change, which then also could be detrimental. So that's be kind of the diagrams you could use there. You could use a bar graph. And then the same data that you would put in a pie graph. Now you have bars that go up. I have 10 of these, 20 of these, 5 of these, 1 of these. And then of course, how are we using this information? Maybe they can find out, weekly. So weekly, there was this much money coming in every week. And then you can start putting together, like, who was working, how many hours were working, to figure out, which combination maybe of your employees gives you the best deal. So there are two types of data that we're going to talk about today. We're going to talk about qualitative and quantitative. Qualitative data is not even numbers. That's what's your favorite ice cream? What's your favorite color? You can't put a number to that. Now, sometimes we can go back and we can try putting numbers to it to make a little bit more sense to it. But generally, what's your favorite subject? Those don't have numbers. But then you go into quantitative, quantity, therefore you have numbers. What is your shoe size? What was your number of sleep? How many hours of sleep you got last night? Those types of things. So when we're talking about quantitative numbers, there's two different types. There's discrete and then there's continuous. So discrete numbers, actually 1, 2, 3, 4s. Continuous is a range of numbers, all the numbers that you could possibly have. So in this particular problem, we're going to talk about the numbers of cherries in 24 boxes that are shown below. So we got some boxes of cherries, someone went out, counted them all. This data, as they say, is discrete because there are 44 in one box, 43 in another box, 42 in another box. And so what they want you to do is create a frequency table. A frequency table, guys, is just how many times does 40, 41, 42, 43, 44, and 45 show up. Now, there's a couple different ways we could do this. I would definitely, when we use a number, I would cross it off. Whoops, wrong marker. Cross it off. So there are two 40s. So then I can go through and count out my 41s. 1, 2, 3, 4. I found 4. Hopefully I'm right. 42. 1, 2, 3, 4, 5, 6. 6. 43. 1, 2, 3, 4, 6, 7. 7. 44. 1, 2, 2. And 45. 1, 2, 3. Now, they did tell us that there were 24 boxes. So 4 plus 2 is 6, plus 6 is 12, plus 7 is 19, 19 plus 5 is 24. So there are 24 boxes. We got all the numbers. So that's how you would set up a frequency table. Now, thinking back to some of the things that we've done before, I think we've done before in this class, it's all running together, is that you could look at this and say, I know the mode. The mode is 43 because there are 7 of them and there's no other group that has 7 numbers in it. I would also know that 40 is my minimum because that's my smallest number. 45 is my biggest number. Now here's a cool thing. Now that I have a frequency table, I could technically make a stem and leaf plot, which we're not going to talk about today. I can make a pie graph now, knowing that I can cut a circle into 24 equal pieces, and I use 2 of them, 4 of them, 6 of them, 7 of them, right? So 7/24 of the circle. You convert that to degrees. It's pretty easy. So, where else are we going to go with this? The length in minutes of 20 phone calls. So, we're in even videos or phone calls. 4.2, 6.8, 10.4. This is what we call continuous data because phone calls don't end on the minute. They could go in between. That's why you have a 0.2, 0.8, 0.1, 0.6. And so they would like to use is a frequency table. It's a different types of frequency table than this one. This is a frequency table. And this one's a grouped frequency table because we're starting to group data together. What they did here is they said, hey, all the phone calls that end up falling between 0 and 5 minutes. 5 to 10 minutes, 10 to 15. Notice what you have here is that they put the equal to with the lower number. So this is equal to 0, not equal to 5. So if you have a 5, it goes into the next group. And we're going to do the exact same thing. I'm going to pause the video to save a little bit of time in the video, but I'll have this table filled in when we come back. So hopefully my numbers are correct. I got 6, 6, 6, and 0, 2. There are no numbers or phone calls that happen to be between 15 and 20 minutes. And I'm scanning through one more time. I think I can agree with that. So why are they different between parts 1 and 2? This one has a grouped data, so therefore I am making the same frequency, but my lists are not as discrete, actually, right? They're not just this many of this number. Now we're talking about ranges of inputs. Then how many do we have? That's our differences. So question, what type of values can discrete data take? Now we talked about those a little bit. Discrete data can be numbers, shoe sizes, pant sizes, the actual sizes. Discrete could be a lot of different things, like how many subjects, how many languages can you speak? How many subjects are you taking right now? How many cars do you own? Those types of things. And you collect the data by, filling it, creating a thing you're going to do. You can create a survey, I guess, for that, or look it up. And then continuous data can be not just your pant size, but what is your actual waist size, and that waist size then would correlate to a particular pant size. Phone calls, obviously, for continuous data, and anything to do with time, minutes, pounds of food maybe that you're collecting. can be between pounds. They don't have to be per things. And it's same things collected. You may actually use different apparatuses, so like a scale or a stopwatch versus just like a ticker, like a click, 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 1, 2, 3, 4 for laps, versus how the actual distance ends up being. So talking about that jeans idea, we have here is the fact that men's jeans are sized by the waist measurement, 28 inches, 30 inches, 32 inches, so on. This is discrete data. It says, do you need to change your answer to what type of values can discrete data take? I don't think so. I think we talked about the fact that it is a number. My pant size is a 28 or it's a 30. Now when you go back to the bottom, and at the very bottom here, it says these are the actual waist measurements. So somebody who's wearing a 24.3 pants, that could be a range between 24 and 25, or 26 actually, because I think they go by twos. The 24-inch waist guy is either going to try to squeeze himself into a 24, right? He's got to squeeze in, or he bumps up to 26 and then has a lot of free range to go in there, those types of things. So these are continuous for the actual waist measurements versus discrete because they're locked in. And we kind of talk about that here. This is a continuous, and then it differs from there. So what are the differences between discrete and continuous? Discrete, actual physical numbers, boom, 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 boom. Continuous is more of a range. And it says that right here. Data is either can be counted, and then continuous can be measured. So that'd probably be a better way of saying that. So discrete and continuous data can be organized into frequency tables or grouped frequency tables, and the continuous data classes must cover the full range of the values and they must not overlap. So that's kind of the biggest thing. So when you're going to do that grouped frequency table, you don't say, hey, I'm going to go from 1 to 5 and then 2 to 3, right? So you don't have 1 is less than X, which is less than 5, and the next group will be, 2.5 is less than X, which is less than 10. No, you can't overlap here. Don't do it. And the next one here, the answer is on the bottom, so we're just going to talk about it. Hey, state whether this data is discrete or continuous. The ages of boys in a football club are. Now, when I first looked at this and I saw 10, 11, 11, 10, 12, blah, 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 I'm like, hey, that's discrete. You're telling me I am 10 years old, or I am 11 years old. But unfortunately, if you actually sit back just a little bit, you would actually say, hey, it's a continuous thing, because we don't say that I am 10.2 years old. I am 10 until I turn 11. So there's really, 12 months of play in there before you officially become 12 years old or 11 years old again. And again, they say that, hey, construct a group frequency table for this data. Now, guys, this does not actually, this might be the only one way you can make it happen. This makes more sense to me because they should have been up here in our data, they should have said, hey, I'm 12 and a half, I'm 12.4, all the way up to 1 out of 12, right? 1 out of 12 months, 2 out of 12 months, 3 out of 12 months. So it makes sense that you have 10 to 11-year-olds. I can go up here in this data table and I could say, hey, there are 7 of them. Essentially, notice that they're saying 10 is included in this group, 11's not, but 11's included in the next group. There's no overlap. And so, notice that we're dealing with 10s, 11s, 12s, 13s, 14s, 15s, and 16s. They don't have 17s, they don't have 9s, they're not including them. So that's why they get their frequencies here. So your homework then is to do 3A. Homework 3A. I think there's only a couple problems there. I do have it posted on Power School Learning. Have a great day.